Hello and welcome to the MLOps Minute. So in this episode, we're going to take the liberty, automatically execute the script that will create AzureML if it doesn't exist, and the necessary dataset if it doesn't exist. Then we'll automatically execute our AzureML pipeline from GitHub Actions. We'll even go one step further, i.e. I'll provide you with a command line, make a fork of the current repo, i.e. MLOps Python demo 1, and automatically create all the secrets, all the configuration in Azure, so that as soon as you run this file, you'll have the pipeline working for you from A to Z. Well, just with our extraction module for now. I'm going to explain everything I've done. The code is already done, and I'll explain it to you. So what I've done here is that the little setup AzureML.h file, instead of hard coding the parameters, we can inject them to run this file here by running setup AzureML. Under subscription ID, parameters 1, parameters 2, parameters 3, 4, voila. The same goes for the script used to execute the pipeline in AzureML. We'll be able to inject parameters dynamically. The biggest changes in the main.iml file, where what happens is that now I've put 3 parameters here in the environment variables. We're going to find the group resources, the location, and the name of the AzureML workspace. The subscription ID is missing because I've put it in the secrets. We'll come back to this a little later. Then in terms of jobs, we already had our job that executes unit tests. Now I've added one, train. This job will only run if the unit test job works. This saves time. If unit tests fail, we won't run our entire pipeline. There's a little notion of environment here. MLOps Python. In fact, we're going to store our secrets in a GitHub environment. We'll come back to this later. I'll go through all the steps first. In the steps, we're going to do a checkout. We're going to make a Git clone of our project without taking all the history. We'll install the version of Python we've configured. Next, we update pip, install poetry, give execution rights to our makefile. Then finally run the makefile we created in the previous episode. This makefile, remember, what does it do? Save the current directory, go to the train directory, poetry install on what allows us to run the AzureML pipeline. Return to the previous directory. Go to the extraction directory. We run poetry install just on this little extraction brick, and we'll generate a requirements.txt file, which will be used directly in our Docker file to make things easier. For the moment, that's all we're doing. We'll execute this file. Next, we'll create an Azure login to authenticate with Azure. And then what's going to happen is that we're going to create an application account in Azure Active Directory. What is Azure Active Directory? In a nutshell, Active Directory is LDAP, database for storing application and user accounts, and it's extremely fast to read. In general, every company uses an Active Directory account. It's important to remember that this system can operate worldwide. In other words, you can have lots of Active Directory accounts in different regions and countries and set up a write, for example, in France. And little by little, there is a system of replication. Writes are replicated in all countries. As a result, we'll be able to make very rapid read accesses to obtain writes. And this system of replication means that sometimes you're given writes. You have to wait a few minutes before they are taken into account because it has to be replicated where you're reading it. We're going to set up a token exchange system with OpenID Connect with an Active Directory account and GitHub action. We'll talk in detail about OpenID Connect because it's important. But for now, we won't go into detail. Just know that we're going to create an application account and use it with GitHub Action. Next, we'll give execution rights to our AzureML setup file. Which we'll be able to execute with our 4 parameters, including the subscription ID, which is a secret. If the Azure ML doesn't exist, we'll create it. And if our dataset doesn't exist, we'll create it. Then we can execute our pipeline with our 4 parameters. Now let's take a look at the secrets. So what is a secret here? If you're admin, you'll be admin of the fork you're about to make. I'll give you a quick demo. Here you have a secret in variables, then action. Who's there on the left? Here you can see all the available secrets. And here I have 3 secrets: client ID, subscription ID, tenant ID, combined with a Python MLOps environment. What is an environment? We'll be able to create an environment that can be shared between several projects. This allows us to isolate our secrets inside. You can create a secret. The idea is that when you create a secret here, I see the value of my secret, which is 0000. I can add to it, but once I've created my secret, I can never get it back. That's for security reasons. Even if in a GitHub action I echo or print this secret, GitHub action won't display it, not so that a hacker can recover your accounts, your secrets. So, secrets and application accounts in Azure Active Directory. We're not going to create them by hand. We're going to automate them. That's what we're going to do. Previously, to perform manipulations in Azure, we used az-cli, which lets you perform manipulations on the command line. We'll now be able to use GitHub CLI, which will enable us to perform manipulations directly on GitHub, in particular to create our secrets on the command line, and that's great. To create all this, I relied on an article by Alexandre Nedelec, which I'll detail in the video description. If you're interested, you can read his article in more detail, which is very interesting. I've modified it to be able to execute it. Then I created 2 scripts. The idea is that you yourself can run them. And just by running them, you'll have everything ready to go. That will work. I created 2 of them. Why did you do this? Because unfortunately, the GitHub login with the GitHub CLI doesn't work in Git Bash. So unfortunately, I had to make a Windows script with PowerShell, which is a bit like Windows Bash, but which now also works on Linux, and Doresh, the classic bash for Linux users. Before describing everything it does, it's best to run it. Here, what I've done is in a demo setup workshop directory, I've copied my 2 files, 2 scripts. I positioned myself inside. You really need to position yourself correctly in the directory. Now I can run my PowerShell script. To run PowerShell in Windows Terminal, I've selected Windows PowerShell. It won't work on a CMD terminal. The first step is to ask me to authenticate to Azure. Here I'm going to use my Gmail account because I have several accounts. Next, it's going to ask me to authenticate with GitHub. It tells me I'm already logged in, but I'm going to re-authenticate for the demo. I'm going to use HTTPS because it's easier to get past the proxies. Then yes, I'll authenticate with a Git credential of my own. And we're going to authenticate with a web browser for the demo. He'll give me a code, and it will redirect me to a page where this code must be entered. But here's the thing. I asked Robert Carey for the video his GitHub account. What you should never do is never share your accounts. But he's nice about the video. He lent it to me. As a result, I have to get my code here so that I can paste it. Moving on. It asks me for rights, lots of rights to create workflows, GitHub action, full control, which is more of an admin right, but that's what I need. See here, I only have one repository. And in fact, what's happening now is that it's forking of this MLOps Python project. It's creating an application account on Azure Active Directory, secrets that it will automatically configure on Robert Carey's account. So here we can see that he's making a fork. The best of all, while he's working, I'll describe the script a little. So here we're going to authenticate on Azure, then we're going to authenticate on GitHub, just like I did. We're going to fork my MLOps Python demo 1 repository. We'll change the name of the fork to MLOps Python my demo. Next, I'll remove the remotes, which prevented me from recovering the correct workspace name. It retrieved Guillaume Chervet instead of Robert Carey. So I did these little commands. Next, we retrieve the name of the GitHub workspace. So here, Robert Carey. We create an environment called MLOps Python. We'll get the name of the subscription ID, and the client ID of the subscription, which I'm connected to on Azure. We'll create an application, an application account in Azure AD. Then we'll create an application account so that we can assign roles to it. And we'll create a role, in this case, contributor, meaning that it will be able to write to and read from our subscription. And here we'll give him a scope that will enable him to completely control all of Azure ML. So it's an ultra high scope. We could limit it. Here the Copilot offers me a resource group name by specifying a precise resource group. In other words, we would only have admin rights in this resource group, but then you can't create the resource group dynamically if you do that. So this account is really admin and can create anything you want on Azure. So you really mustn't lose out. Here we're going to set parameters specific to OpenID Connect to create a token exchange system between GitHub and Azure. We'll convert this configuration to JSON and create this token exchange configuration. And finally, we'll put the secrets automatically into GitHub and trigger our workflow. And we'll even be able to see what's going on and open the web page on this page automatically as soon as it's finished. I hope my script worked. I've got a feeling I might have damn, it asked me to authenticate again. I don't know why. So now it's creating my environment. It's going to create my application accounts, which in my case, as I've already tested, already exist. So it's going to take them over, and here it's going to make a few errors, but that's normal because I've already created the project. I've already tested it, and I deleted the repository to redo the demo. So that's it. It is finished. It's going to run me this page. But right now I'm using my server account, so I'm not admin. Here I can go to MLOps Python my demo. Normally, it should have triggered a main.iml file, but I don't think it did because I already have a creation history. I've done lots of tests on this account, but with you, it should work. Here, in the secret and variable, automatically it created my environment and gave me the secrets. Which means that if I play the workflow, by default, a fork doesn't play GitHub Actions. You have to activate them. And if I play my workflow, how are we going to execute it? Main.yml. I'm going to do something you should never do, but I'm just going to make a small modification so that it runs. I don't think this is the right way. Will he execute me? No, it won't. How do I trigger it? My little modification executed it, a trigger, a GitHub action. And now, indeed, my unit tests are going to run, the Azure login is going to work, and my pipeline is really going to be triggered in AzureML. And now I'm really happy because in one command line, if you play this file at home, everything will run automatically. And in MLOps, that's what we want, because later on, we'll want to scale, i.e. make projects in a chain, and that's one of the keys to scale. Thank you, and see you soon for more videos.